Hello there! Let's now put some of the stuff we've been talking about into practice by going back to our project and convert all our pixel units to REM. And I'll explain you why, of course. So in this lecture, you're going to learn how and why we use REM units in our project, and why you should do the same. And of course, a workflow to convert pixels to REM in the easiest way. So this is what we're going to do in this lecture. We will change all the absolute pixel units to relative REM units, okay? And why are we going to do that? Well, it's quite simple actually. It's because we want an easy way to change all the measurements on our page with one simple setting. For example, when we hit a breakpoint to display our page on a mobile device. When that happens, we want a way to decrease all the measurements in our site at the same time. And instead of writing hundreds of lines of code in the media queries, we can just change one global setting, and that is the global font size. So let me show you how this awesome technique works. So you remember how the REM unit is always in relation to the root font size, right? So if we now set that root font size, we can then very easily change all the other measurements on our page to REM. So let's do that. So the root font size is set in the HTML selector, okay? And so we say font size 10 pixels. Not the 16 that we had before, but 10. I'm actually going to remove this one, but just commenting it out so it stays here for you to see. And so so I changed this to 10 pixels. But now, why did I change it to 10 pixels? Well, we do 10 pixels here in order to make our life easier, to be honest. That's because now we know that 1 rem equals exactly 10 pixels, right? Because remember, 1 rem is exactly the root font size. So if 10 pixels is now the root font size, then 1 rem is 10 pixels. And so now it's really easy to replace all the pixel units with rem. Because all we have to do is to divide all the pixels by 10, and that's our rem, right? Now if it was 1 rem is 16 pixels, then we would have to make a lot of calculations. And we don't want to do that, of course. So this is a pretty common technique to avoid that, okay? So with this in mind, let's actually do that. So we start here at the top and change all, or let's say most, of our pixel measurements to rem. So we have a 30 pixel padding. So just divide it by 10 and you end up with 3 rem. Okay, and that's it. So let's keep looking. What do we have here? Oh, another one, 40 pixels. So it's 4 rem, right? So you don't have to do any calculations. You just divide it by 10. 4 rem. And here, 3.5 rem. Right? It makes sense, right? And I will actually show you the effect of this in a second, okay? So here we have percentages, nothing changes. Here, 6 rem. Here again, 6 rem. And here, 3.5 rem. The font size here should be 2 rem. Here it's 1.74 rem. Well, that's a bit specific. Let's just keep it at 1.7 rem, okay? Or we can say 1.75 rem. Okay, that looks acceptable. Now here we have minus 10 rem. Here just 1. And 10. And minus 1. Okay, so ideally, of course, you start by doing this right in the beginning of the project. But I didn't want to overwhelm you and to scare you with all too much theory right at the beginning of the course. And so we just started the simple way, and the way you probably already know how to do everything, which is in simple pixels. But if you're doing responsive design and modern CSS development, then it's really good practice to use relative units like rem. So here we have 3 rem. Now, of course, we could also have used ems instead of rems, but that's a whole lot of work. Believe me, I've tried it, and it's really difficult to make. Because remember that the ems depend not on the root font size, but on the font size of the parent element. And with that, you have to do a lot of calculations, and it becomes really, really difficult to manage. So I always set everything to rem, and then it's really the best solution. 1.5 rem, 4 rem, and 10 rem, of course. Here, we can also do it here in these box shadows. And here it's 0.5. So whenever you have a point, you don't write out the 0 in CSS, okay? So it's of course you can, it works, but it's like, let's say, a coding practice to only put the dot, okay? It's just a good practice that professionals use. So 10 rem in here. Any more pixels? That's it. All right. So let's now take a look and see if everything's still working the same. All right, great. The only thing is here, the text size here, because originally we set it to 16 pixels, right? And so now here we actually have to set the font size. Well, yeah, here it is. So if we still want it at 16 pixels, then it should be really easy, right? So 16 pixels is 1.6 rem. So let's go back. And here we go. Great. Now what I want to show you is this. So if we now go ahead and just change the overall font size, so yeah, here it is, then see how the entire design changes. So I go down to 9, and you see that everything changes, everything became smaller. Take a look at the padding here outside, at this padding, and here at this size, and also the text size, as I will decrease it further. Sorry, this was increasing, so I decrease it further now. Everything is becoming smaller, right? And that is amazing once we start writing media queries. It will make our lives so much easier. So imagine we had now this smaller version like on a phone, and then this would already take a lot of work from us. Instead of writing all the media queries to make all the font sizes smaller and to make all of these distances here smaller, like these 30 pixels, this now automatically converts to something else. For example, in this, well, this is now really small. Let me check this. Where is it? This body. It has now a padding not of 30 pixels, but of 15 here, as you can see down here. You see, now it's 15 pixels and not the 30 that it was before. And that's because we set the font size here to 5, right? So 5 is half of 10, and so 15 is half of 30, right? If we put it back like to 8, then the padding becomes 24, and so forth, and so on. And the same would, of course, work in the other direction. So imagine we have a really huge screen or something, and we want to increase our design. Or someone zooms in the page, and that's what happens. So we can also write media queries for larger screens and then increase the design. All right, so that is the trick and the huge advantage of using REM. Now we can still improve this because it's actually a very bad practice to set the font size to pixels as well. So up here, this shouldn't really be 10 pixels. It should be something else. The problem is that by doing so, we actually override the browser font size setting that the user can manually change in the settings. And many people actually do that. For example, when they have bad sight and cannot see so good, then some people actually increase the default font size of their browser. Now, if we set the font to like the 10 pixels like we did here, then we remove the ability for these people to see our website properly, because they can no longer change the default font size. Well, they can, but our root font size will not be affected by that anymore. It will just be 10 pixels no matter what the user has as a default font size. So this is really a bad practice. And that is why we're going to set the overall font size to a percentage here, which will translate to a percentage of the font size given by the browser. Now, the default font size, if the user doesn't change anything, which is the initial situation that we want, is 16 pixels. So that's the absolute default. And that's the situation that we're counting on here. So if we put 100% here, this would mean that the root font size would be 16 pixels if the user doesn't change anything. And if the user does change the default font size, let's say to 18 pixels, then the root font size would be 18 pixels. If he changes to 20 pixels, then it would be 20, and so on and so forth. Now, but we don't want 16 pixels here, right? What we want is 10 pixels. And so it's very simple. All we have to do is to divide what we want, which is 10, by 16. So I'm having a calculator here. So 10 divided by 16 is 62.5%. And that is what we're putting here, 62.5%. And that's it. That's the whole technique. So now imagine, let's say 0.625. So if the default is 16 like we had before, then this translates to 10 pixels, right? Which is what we want. But if the user changes to, let's say, 20 pixels, then our default font size will be 12.5 pixels. So the root font size, I was saying. And if the user does 22, it goes to 1375 pixels, and so on and so forth. And so with this, we allow the user to actually zoom in on the page automatically, not only to change the font size, but to also zoom in on the page, because basically that's what happens. Not exactly zooming, but increasing all of the measurements that we have on our page. So make sure that you understand this technique. It's really widely used in the CSS developer community because it's so simple and yet so powerful, as you saw. Now, one thing that I should probably tell you is that REMs are not supported below Internet Explorer 9, okay? So if you have to develop a site for one of these browsers, so the really old Internet Explorers, then you cannot use REMs because your site will simply not work at all, okay? Now, since that applies to almost everything that I'm going to show you in this course, I guess that's not really relevant at all. Because if you're interested in taking this modern course that you're taking right now, then you're probably not trying to develop for these old browsers anyway, right? Alright, and one more thing we can do before we finish this lecture is to use the power of inheritance, since we already talked about inheritance, right? So whenever we can use inheritance, we should use it instead of using here something like the universal selector, okay? And so what I'm going to do now is to remove this box sizing from here and put it here on the body. Okay, so now we set the body to box sizing border box, and then in here what we do is to say box sizing, and we use the inherit keyword. And that's it. So remember how we could use the inherit keyword to force inheritance. That's what we're doing here. So the box sizing property by itself is not inherited, but by setting the box sizing property on each and every element on the entire page to inherit, it will automatically inherit whatever we put here on border box. So this is considered a slightly better practice by the CSS community because it makes it a bit easier to change the box sizing, like in plugins or other components where we might want to use a different property for box sizing. Okay, so it doesn't make a huge difference, it's just a slightly better practice to do the box sizing border box like this. Alright, and since we're at it, we should actually update this universal reset here, because we can do slightly better than this, which is to also select all of the after pseudo elements and also all of the before pseudo elements. That's because right now only the real elements get this behavior here, but the after and before pseudo elements, they don't get this behavior. And since we don't want to see any strange behavior happening, we will also include these ones here as well. So, you know, we already have a after pseudo element down here, and if we had put a width or a height and then a padding or a border, then it wouldn't have behaved the way we expected it, which we expected because of the box sizing of border box. So actually it's down here. So it wouldn't have worked the way we expected because we actually didn't have this part here in the universal selector in our global reset. Okay, so just another slightly improvement over our previous code. Okay, and that's really it for this lecture. See you in the next video. Welcome back. Do you still remember the diagram that I showed you in the beginning about how CSS works behind the scenes? This one, right? So we've been talking a lot about the parsing phase, but now it's time to move on to the website rendering phase. So this lecture should give you a pretty good overview about how the visual formatting model works so that you can write your code in a way that makes more sense to you. What this lecture will do is maybe not so much give you new tools, but it will summarize a lot of the CSS that you actually already know and put it in a more meaningful context. So, the CSS visual formatting model is an algorithm that calculates boxes and determines the layout of these boxes for each element in the render tree in order to determine the final layout of the page. This model is one of the fundamental concepts of CSS, which is why I decided to include it in the course. Now, in order to do this, the algorithm takes into account factors like dimensions of the boxes, which are calculated by the box model, the box type, which can be inline, block, or inline block, the positioning scheme, which includes concepts like floats and absolute or relative positioning, stacking context, the other elements that are present in the render tree, such as siblings or parents, and finally, external information such as the current viewport size, dimensions of images, or other factors. So by putting all of these factors together, the browser figures out how the final website will look for the user. So let's now look at the first 4 of these factors in more detail. And let's start with the box model. The box model is without a doubt one of the most fundamental parts of CSS, and it's something you really have to master in order to lay out a web page. The box model is one of the factors that define how elements are displayed on a web page and how they are sized. According to the box model, each and every element on a web page can be seen as a rectangular box, and each box can have a width, a height, a padding, margins, and a border. But note that they are all optional, so there can be boxes with no margins or no paddings at all. Now this image here shows us how the box model works. So let's break it down. First, the content of a box is where all the text, images, or other content that we specify go. We can easily define its height and width using the corresponding CSS properties, as we're going to see in the next slide. Next, the padding is a transparent area around the content, but still inside of the box. We use paddings to generate white space inside of a box, and we can define the padding by specifying the padding property in CSS, as I'm sure you already know. Next, we can specify a border for a box, and that border goes around the padding and the content. Similar to the padding, we have the margin, but instead of being inside the box, the margin is white space that's actually outside of the box itself. So we can think of margin as the space between boxes. So, for example, if we want some space between 2 elements, we will define their margin properties in CSS. And finally, there's something called the fill area. Remember how the text content in images go inside the content box? The same does actually not apply for background images or the background color of a box. These properties will be applied not only to the content box, but to the entire fill area, which also includes the padding and the border, but not the margin. Alright, so let's now talk about heights and width in the default box model. As I mentioned, we can specify the height and the width of an element. Now, if we choose not to specify the height or width of a certain element, the visual formatting model will just use the content of the box to determine its size. So let's now take a look at how the default box model calculates heights and width of block level boxes, and more about block level boxes or elements later. So, the width of a box, as we will see in the final layout, is defined by the right border plus the right padding plus the specified width plus the left padding plus the left border. And the same logic, of course, applies for the height of the box. But let's look at a quick example to make this more clear. Suppose we define the height for an element of 100 pixels and a padding to the top and bottom of 20 pixels. So the final height, as displayed on the website, would be 140 pixels. This means that whenever we define a width or a height of a box, the padding and border get added to what we defined. But that doesn't sound very practical, right? So the solution to fix the problem is to use the box sizing property with the value of border box. And I'm sure that many of you already know and use this trick, and I also showed it in my beginner HTML and CSS course. But it's still important to remember how this actually works. So, if we set box sizing to border box, the height and the width will be defined for the entire box, including the padding and the border, and not just for the content area. What this means at the same time is that the paddings and borders that we specify will of course reduce the inner width of the content area, instead of adding them to the total height or width of an element. Alright, so if we look at the height and width calculations now, in this case, the actual total width of a box is equal to the specified width. And the same goes for the height. So if we now define some paddings or borders, they will not get added to the dimensions of the box, which makes our lives so much easier. And if we look at our example now, the final height would of course be 100 pixels, just as we specified for the height of the element. Alright, so we looked at the box model and how height and width of boxes are calculated. But this applies mainly to block level boxes, which is one of the different types of boxes in CSS. So let's now look at the three most common and most important box types, and how different box types determine how boxes are laid out on a page. Let's start with the block level box or element. We can say both. Now, first off, the type of a box is always defined by a display property, which I'm sure you know already. So in the case of the block level element, the display property is usually set to block. But please note that the values flex for flexbox layout, list item, and table also produce block level boxes. Now, all HTML elements have a default display property, and elements such as paragraphs or divs, which are usually formatted visually as blocks, have their display property set to block by default. We can always, of course, change this property manually, which can be very useful in some cases. Okay, so being a block level box, this box will always occupy as much space as possible, which is usually 100% of its parent width, and create line breaks after and before it, meaning that blocks are formatted vertically one after another. Now, about inline boxes, they're basically the opposite of block level boxes, because their content is distributed in lines, meaning that an inline box only occupies the space that its content actually needs. Therefore, they also don't cause line breaks after or another them, but instead, they just sit inside their block level parent element. Now, about the box model, things work a bit different in inline boxes. First, the height and width property do not apply, which means that we cannot use these properties here. And second, we can only specify horizontal paddings and margins on inline elements, so only on the left and on the right side. That's the way the box model works on inline elements. So of course this has some serious limitations, and in order to overcome them, there's another type of box, and that's the inline block box. Now, inline block boxes are technically also inline boxes, but which simply work as a block level box on the inside. So, since they are technically inline elements, they also use up only their content space and cause no line breaks. But, since they work as a block level box on the inside, the box model applies to them just like in the regular block level boxes. All we need to do in order to set an element to an inline block is to set its display property to inline block. And that's it. Very easy. So it's really important that you understand the difference between these three types of boxes so we can use them as needed in different situations. Okay, next up we have positioning schemes. There are three of them in CSS: the normal flow, floats, and absolute positioning. And I'm sure you're already familiar with floats and absolute or relative positioning, and so this is more to bring all of these properties together into a bigger context. So, the normal flow is what happens to an element if you don't do anything to it at all. If you don't float it, and if you don't use position absolute on it. If you use position relative, then the element is still in a normal flow. And what the normal flow means is that the elements are simply laid out on the page in a natural order in the code. The next positioning scheme is when you use floats. The float property causes an element to be completely taken out of the normal flow and shifted to the left or right as far as possible until it touches the edge of its containing box or another floated element. When this happens, text and inline elements will wrap around the floated element. Also, when an element is floated, its container will not adjust its height to the element, which sometimes can be problematic. The usual solution to this is to use clear fixes, which I'm sure you have used when building layouts using floats, right? And then finally, there's absolute positioning. And just like with floats, when you set the position property to absolute or also to fixed, the element is taken out of the normal flow. Now, what's different here is that with absolute positioning, the element has no impact on surrounding content or elements at all. In fact, it can even overlap them. So if we want to position an absolutely positioned element on a page, we use the CSS properties top, bottom, left, and right to offset it to its relatively positioned container. Now, as I mentioned, an absolutely positioned element can overlap other elements occupying the same space. And how do we solve this? Well, CSS solves it for us actually, using something called stacking context. So there's one piece left in the puzzle of the visual formatting model, stacking contexts. So, stacking contexts are what determine in which order elements are rendered on the page. A new stacking context can be created by different CSS properties, where the most widely known is z-index. But there are other properties that also create new stacking contexts. Now, stacking contexts are like layers that form a stack. Layers on the bottom of the stack are painted first, and elements higher up the stack appear on top, overlapping the elements below them, just like you see on the slide. In this example, we have 3 stacking contexts, because each element uses the z-index property on an either relatively or absolutely positioned element. And that's one way of creating a new stacking context. Now, between these elements, the one with the higher z-index appears on top, and the one with the lowest z-index appears at the bottom. Now, a common misconception is that only the z-index property creates new stacking contexts, but that's not the case. An opacity value different from 1, a transform, a filter, or other properties will also create new stacking contexts. That's why sometimes, even with a z-index set on a positioned element, the stacking order doesn't work as expected. But as with everything we talked about in this section, we will see practical applications of all of this in the coding part of the course. To finish this section, let's put something that we learned in the last lecture into practice right now. And that's to convert the HTML we've been writing so far into the BEM system, so that we can start using BEM from now on. So in this lecture, you're just going to learn how to use the BEM method in practice. And there's actually not a whole lot to do here already, because we haven't written so much HTML up until this point. One thing that we have to do though is to identify our first block here, and that's the header here, okay? So the header is obviously a block in the BEM system, because it is a standalone component that is meaningful on its own. And so it's a block, and so all the elements that are inside it should also have the header attached to them, right? So this logo box here, it can only really exist here in this header. And so it's an element, right? Because it's part of a block, but it has no standalone meaning. And so we should now start adding the header to the elements. So header, and now remember, it's double underscore to separate the block from the element. So header is the block, and logo box is the element. And the same thing here for a logo. So we call it header logo. Because this logo with this exact size and this exact image, it only just exists here in the header. The same goes, of course, for this text box. So header, text box, simply because this text box is a part of the header and it doesn't make much sense to use it anywhere else. Now, as for this heading primary here things are a bit different actually, because we could treat this as a block on its own. Imagine that we wanted to use this h1 element somewhere else. Imagine we had another page, but without a header like this one, and we wanted to use this primary heading. We could of course do so. And so this one here is a standalone block. Now, as for these two here, what do you think about them? They are called heading primary main and heading primary sub. So what these two are, they are actually modifiers of the heading primary, right? Because they simply create a slightly different version of this heading primary class of the block, right? And so what we do is that we put 2 dashes here. So remember, block, and then if we have a modifier, we do dash dash and then the name of the modifier. If it's an element, then we use underscore underscore and then the name of the element after that, right? Okay, same thing down here. A button is of course a standalone component, so we can consider it a block in the BEM notation. Of course, because we're going to use this button throughout this entire page. Now here, these two can be considered flags as well, such as we had before, right? And so we use double dash on both of them. Because this is still a button, but they do simply create different versions, different modifications, and that's why they're called modifiers, right? And that's actually all we have to do here in this markup. So we now have this converted to the BEM notation. So let's just go back to the style and change it here as well. So header, and let me just actually copy this part. So header, then here we had header logo and header text box. and heading primary. Okay, so here just a dash missing, another dash. Here everything stays the same. Button, everything is good. So here another dash to create this difference. And here for the animated. Alright, that's actually it. So our code is now converted to BEM. Let's just check if everything is the same here, which of course it should. And well, something happened here, so something is clearly wrong. So let's go back to check if our CSS is completely correct. So let me see if I forgot something here. Primary sub and main. Okay, so here the T is missing. I guess that was the problem. Yeah, it probably was. Well, there's another bug somewhere, I guess. Ah, okay. That's because I put the T in there accidentally. Alright, but now it should work. And here we go. So everything is back to the same. Our code is now converted to BEM, and we're good to go. And that actually wraps up this theoretical section. I believe that it was rather intense and rather sometimes hard to grasp, but as I said so many times already, I know that it's really important to go through these more theoretical and fundamental aspects of the CSS language if you really want to grasp it and become more professional in it. So great job, great progress. It's amazing that you're still with me, and you now deserve some break or some rest if you need. Well, and if you don't, then just continue to the next lecture and I'll be waiting there for you.